You ever think about what holds up a skyscraper? It ain't magic, folks. It's a marvel of engineering and human ingenuity. It's a solid foundation hidden beneath the ground, doing the dirty work. This foundation is meticulously planned and executed to ensure stability. Foundations are the unsung heroes of construction, taking on the immense weight of entire buildings and transferring it safely to the earth. They are designed to handle various stresses and strains. Without a strong foundation, even the most impressive structures are doomed to fail. History is filled with examples of buildings that crumbled due to weak foundations. It's like building a house on sand, a recipe for disaster. The ground beneath must be solid and well prepared. That's why engineers spend years studying the ground, figuring out how to create a base that can withstand the test of time. They analyze soil samples, conduct tests, and use advanced technology. Think of it like this. The foundation is the backbone, the guts of any building. It supports everything above it, ensuring safety and durability. It's the silent workhorse holding everything up, allowing us to enjoy the view from that fancy skyscraper or the comfort of our own homes. Without it, our modern world wouldn't be possible. So next time you walk into a building, take a moment to appreciate the unseen hero beneath your feet, the foundation. It's the cornerstone of our architectural achievements. Now, not all dirt is created equal. Each type of soil has its own unique characteristics and properties. Just like people, soil comes in different types, each with its own personality and quirks. Some soils are more suited for certain tasks than others. You got your clays, your sands, your silts. Each one behaves differently under pressure. Understanding these differences is crucial for any construction project. Clay, for example, is like that friend who's always clinging on. It's dense and sticky, making it difficult to work with. It absorbs water like a sponge, expanding and contracting with the seasons. This can lead to significant changes in volume and stability. This can spell trouble for foundations, causing them to shift and crack under the pressure. Engineers need to account for this when designing structures. Then you got sandy soil, which is more laid back. It's loose and granular, making it easier to work with, but also less stable. Water drains through it quickly, so it's generally more stable. However, it doesn't hold together well, which can be a problem. But build on loose sand, and you might as well be building on a beach. Things are going to move. Proper compaction and stabilization are key. Understanding the soil is job number one for any engineer worth their salt. They need to know the soil's properties to make informed decisions. They've got to figure out what they're working with before they even think about pouring concrete. Soil testing and analysis are critical steps in the process, because building a foundation is kind of like baking a cake. Get the ingredients wrong, and the whole thing falls apart. The right soil ensures a strong, stable foundation. Sadly, sometimes foundations do fail, and the consequences can be disastrous. Take the Leaning Tower of Pisa, for instance. That iconic tilt, that's a foundation problem, folks. Built on unstable soil, the tower started leaning even before they finished building it, and it's not just ancient structures that are at risk. The Millennium Tower in San Francisco is a modern-day example of what happens when foundations go wrong. This fancy skyscraper started sinking soon after it was built, and now it's leaning like a drunken sailor. These failures are stark reminders that even the most skilled engineers can't ignore the laws of physics. When foundations fail, it's not just about money and repairs, it's about people's safety and the trust we place in the built environment. So what causes these foundations to crumble? Well, sometimes it's Mother Nature calling the shots. Earthquakes, floods, and even just plain old time can weaken foundations and lead to problems down the road. But more often than not, foundation failures are a result of human error. Poor drainage is a big one. When water builds up around a foundation, it's like putting extra weight on a horse's back. Eventually it's going to buckle. And then there's just plain old shoddy workmanship, cutting corners, using cheap materials, or not following the engineer's plans. That's a recipe for disaster. Building a foundation is a bit like surgery. Precision is key. The good news is foundations don't usually fail overnight. They usually give us warning signs like cracks in the walls, doors and windows that stick, or floors that slope like a slip and slide. These are all red flags that something's not right down below. Ignoring these signs is like ignoring a toothache. It's only going to get worse. If you notice any of these issues in your home or building, don't mess around. Call a qualified engineer or foundation specialist right away. Early detection is key when it comes to foundation problems. The sooner you catch them, the easier and cheaper they are to fix. So, don't bury your head in the sand. Pay attention to those warning signs and get professional help if you need it. Now let's talk solutions. When it comes to building structures that stand the test of time, the foundation is key. Without a stable foundation, even the most well-designed buildings can face serious issues. Engineers have developed a whole arsenal of tricks to make sure foundations are built to last. These techniques are the result of years of research and practical experience in the field. One of the most important is soil testing. This step is crucial because the type of soil can greatly affect the stability of the foundation. Before they even start digging, engineers will take samples of the soil to figure out what they're dealing with. These samples are then analyzed in a lab to determine their composition and properties. Depending on the soil conditions, they might recommend different types of foundations. Each type of foundation has its own set of advantages and is chosen based on the specific needs of the project. For example, if the soil is weak, they might use deep foundations like piles or caissons which are driven deep into the ground to reach more stable layers. These deep foundations provide the necessary support for the structure above. Another important factor is drainage. Proper drainage ensures that water does not accumulate around the foundation, which can weaken the soil and compromise the stability of the structure. Engineers will design drainage systems to keep water away from the foundation, preventing it from weakening the soil. This involves careful planning and the use of various drainage techniques. This might involve installing French drains, sump pumps, or simply grading the land to direct water away from the building. Each of these methods helps to ensure that the foundation remains dry and stable, providing a solid base for the structure. These days, engineers have access to some pretty amazing tools and technologies to help them design and build better foundations. Ground-penetrating radar, for example, allows them to see beneath the surface and identify potential problems before they even start digging. Computer modeling software helps engineers simulate different scenarios and optimize their designs for maximum stability. And new materials like high-strength concrete and fiber-reinforced polymers are making foundations stronger and more durable than ever before. All this technology is pretty impressive, but it's important to remember that it's just a tool. The most important ingredient in any successful foundation is still good old-fashioned engineering know-how.